Hey guys, how's it going? Mr. Mitchell here. In this video we're going to go over 3 worked examples to show you how to do problems involving LEDs. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you'll be able to apply what you learned in that video to this one. So let's get started. Question 1 says that a circuit containing an LED is shown below. So we've got an 8V battery and then the LED with its series resistor, and it gives us some LED data. So it says the voltage across it is 2V and the current passing through it is 30 milliamps. Part A says to state the voltage across the series resistor R. So notice the word state means that we don't really have to do much work here. So what we need in order to answer this is the rule for voltage in a series circuit. So remember, the rule is that the voltage across the components in the circuit must add up to give the voltage across the supply. So this 8V here is the total voltage of the supply, and if we've got 2V across the LED, then that must mean that there's 6V across the resistor R. So writing this down with some working, we can say that VR equals Vs minus VLED, where Vs is our supply voltage, and we can then put in our numbers to have 8 minus 2, which gives us 6V. Part B says to calculate the resistance of R when the LED is operating correctly. So this just means when the LED is operating at its 2V with the current passing through it. So if we look back at the circuit diagram, what we need to realise is that it's a series circuit, so the current passing through the LED must also be the same as the current passing through the series resistor R. So the current passing through the resistor is 30 milliamps, and we now know the voltage across the resistor is 6V as well. So we can use this to find the resistance of the resistor. So writing down what we know from the question, we're trying to find R. We know that VR is 6V and the current I is 30 milliamps. So writing this in amps, we have 30 times 10 to the minus 3 amps, and writing down our equation, we have VR equals IR. Rearranging for R, we can divide both sides by I to get R equals VR over I, and substituting in the numbers, we get 6 divided by 30 times 10 to the minus 3, and if you put that into your calculator, you should get an answer of 200 ohms. Part C then says, why must the LED have a resistor in series with it? Well, remember, this is to protect the LED from too large a current passing through it. Question 2 then says an LED operates on 4.2V and 10 milliamps from a 5V supply. What value of resistor is connected in series with it? Well, notice first of all that we are given data about the LED, but are asked about the series resistors. So this is just like the case in question 1. So in order to find the resistance of the series resistor, we need to find the voltage across the resistor and also know the current passing through it. Well, finding the voltage across it first of all, well, remember the voltage across the components in a series circuit needs to add up to the supply voltage. So to find the voltage across the resistor, we can say VR equals Vs minus VLED. So we have 5 minus 4.2, which gives us 0.8V left over across the resistor. We also need to be aware that the current passing through the resistor is going to be the same as the current passing through the LED because it's in series with it. So this means we'll have 10 milliamps passing through it. So we can say that R is what we're trying to find, the voltage across the resistor is 0.8V from this calculation here, and the current I is 10 milliamps, which we can rewrite as 10 times 10 to the minus 3 amps. Writing down our equation, we have VR equals IR, and rearranging for R, we get R equals VR over I. Substituting in the numbers, we get 0.8 divided by 10 times 10 to the minus 3, and putting this into your calculator, we should get a final answer of 80 ohms. Lastly, question 3 says that 5 LEDs are connected as shown. So we have a 3V battery, a switch S, and then 5 LEDs with their series resistors in parallel. It then says that the LEDs each operate at 1.8V and 30 milliamps. So that means each LED has 1.8V across it, and there's a current of 30 milliamps passing through each of these branches here. Part A says to find the value of the resistance of each resistor. Well, what we can do is we can just choose one of these branches to think about this, because remember, they're all going to be identical. So if we're trying to find the resistance of one of the series resistors, then we need to find the voltage across one of the resistors first and the current passing through it as well. The first thing to notice then is that just like we did in questions 1 and 2, if we know the current passing through the LED there is 30 milliamps, then that means the current passing through the resistor is also 30 milliamps. And if the voltage there is 1.8V, then in order to find the voltage across that resistor, then if we ignore all these other branches for now because they're not important just now, then we can say that these two things are in series, and these two voltages need to add up to give the voltage across the supply of 3V. So if that's 1.8V across that LED, then there must be 3 minus 1.8, which is 1.2V across that series resistor. So writing down our working then, it says we're given data about the LED, but are asked about the series resistor. So VR equals Vs minus VLED, and substituting in the numbers we get 3 minus 1.8, which is 1.2 volts as I said earlier. And so writing down what we know, we're trying to find R. We know that VR is 1.2 volts and the current is the same as the current passing through the LED, which is 30 milliamps. So this is the same as 30 times 10 to the minus 3 amps. So writing down the equation, we get VR equals IR. Rearranging for R, we get R equals VR over I, and substituting in the numbers gives us 1.2 divided by 30 times 10 to the minus 3, which if you put into your calculator, gives an answer of 40 ohms. Part B says, what is the total current flowing through the power supply? Well, to do this, we need to be aware of the fact that in a parallel circuit, current splits up across each branch. And if we look back at the circuit diagram, you'll notice that the current will be flowing through the battery in this direction, and it will come along here, and then it will go along this branch and split, and we're told that that's 30 milliamps along there, 30 milliamps along there, and so on for each branch. So if we want to find the total current there, then we need to take into account the fact that we know the current in each branch just now, and the fact they're going to add up when they reach this region over here and come back through the battery. So if we write down what we know from the question, we're trying to find the total current IT. We know that I1 is 30 times 10 to the minus 3 amps, but so is I2, I3, I4 and I5 for our 5 branches. So because we have 5 branches that have the same current passing through them, then as we said earlier, we can add them up to find out what the total current is passing through the power supply. So IT equals I1 plus I2 plus ... plus I5, just ignoring the I3 and I4 to be a bit quicker there. And so this is the same as saying 5 times I1 because we know what I1 is, and it's identical to the other currents. So substituting in the number there, we have 5 times 30 times 10 to the minus 3, which is the same as 150 times 10 to the minus 3, or 0.15 amps. Lastly, part C says, what is the resistance of the whole circuit? So we're trying to find RT here, and we know the supply voltage Vs is 3.0 volts. This is also kind of the total voltage, you could call it, and our total current is 0.15 amps. So we have V equals IR in the form Vs equals IT RT, and rearranging for RT, we can divide both sides by IT, which we've just calculated, to get RT equals Vs over IT equals 3.0 over 0.15, and if you put this into your calculator, you should get an answer of 20 ohms. That's all for this video, folks. I hope you found it useful. If you did, give it a like, subscribe to the channel, and I'll see you in the next one. Take care.